For many years, hydrostatic pressure measurement has been the most important measuring principle in continuous level measurement. What is meant by hydrostatic? The effect of the weight force of a stationary liquid on a measuring point. This weight force is usually described as hydrostatic pressure. The most important condition for hydrostatic level measurement is what is called the hydrostatic paradox. This means that, regardless of the shape and volume of a vessel or tank, the hydrostatic pressure at the measuring point of a tank or vessel is proportional only to the filling height. Thus, the hydrostatic pressure at the measuring point is solely proportional to the absolute filling height, and not to the filling volume. Since the hydrostatic pressure is not dependent upon the volume or the shape of a vessel, it can be used directly for the measurement of the level. In order to determine the fill quantity from the hydrostatic pressure with a high accuracy, the pressure sensor should be positioned, ideally, at the height of the required zero-level measurement. Based on this measuring point, the sensor will measure the hydrostatic pressure as a direct scale of the distance from the selected measuring point. Differential pressure level measurement. There are fundamentally two ways to measure level of a fluid in a vessel, which are 1. Direct level measurement. 2. Inferential level measurement. Float, capacitance, radar, ultrasonic level measurement falls under direct level measurement technique, whereas weight and differential pressure level measurement comes under inferential level measurement technology. Differential pressure transmitters are probably the most widely employed devices for the purpose of level detection. Using DP for level is really an inferential measurement. A DP is used to transmit the head pressure that the diaphragm senses due to the height of the material in the vessel multiplied by a density variable. Differential pressure level measurement technique makes use of a differential pressure transmitter which is installed at the bottom of the tank whose level is to be measured. In case of open tanks, only high-pressure ends of the DP transmitter is needed to be connected, whereas the low-pressure end of the DP transmitter is expelled into the atmosphere. Hence, the differential pressure happens to be the hydrostatic head or weight of the fluid contained in the tank. The highest level detected by the differential pressure transmitter usually depends upon the maximum height of fluid above the transmitter, whereas the lowest level detected is based upon the position where the transmitter is attached to the tank or vessel. The liquid inside the tank creates pressure which is comparatively higher than the reference atmospheric pressure, and the DP transmitter senses the head pressure developed by the height of the liquid in the tank. This is multiplied by a density variable to get the correct level measurement. Now, in cases where tanks or vessels are not open to the atmosphere, that is in pressurized or closed tanks, both the high and low pressure ends of the differential pressure transmitter are required to be connected. These tanks are entirely covered in order to avoid release of vapors or steam outside. Due to this, the liquid inside the tank gets pressurized. The low-pressure impulse line is connected at the top of tank where vapors or gases are present. The weight of the vapors in the low-pressure impulse line affects the differential pressure measured by the DP transmitter. This type of pressure connection is known as a dry leg. The differential pressure measured by the DP transmitter is used to measure the tank level. A dry leg enables the differential pressure transmitter to compensate for the pressure pushing down on the liquid's surface. It is recommended to maintain a dry reference leg since buildup of condensate or other fluids have tendency to introduce errors in the level measurement results. In situations where the vapors of the process fluid tend to condense at standard ambient temperatures, the reference leg or LP impulse line cannot be kept dry. It must be then filled with an liquid to produce a wet reference leg. In a wet leg system, the low-pressure impulse line is completely filled with liquid and hence the name wet leg. The wet leg affects the differential pressure readings and found in negative also. The differential pressure measured by the DP transmitter is used to measure the level of the tank. Advantages and limitations of hydrostatic level measurement. Hydrostatic pressure and level measurement enjoys a consistently high popularity due to its high robustness, high reliability and simple installation of this technology. The following characteristics constitute the greatest advantages and limitations over other measuring principles. Advantages: proven and established measuring principle with higher reliability, field tested millions of times. Robust measuring process, uninfluenced by disruptive factors such as dust, foam, vapor, buildup, contaminants, etc. Reliable measurement unaffected by many physical characteristics such as conductivity, dielectric coefficient or viscosity. Level measurement unaffected by vessel geometry and existing installed equipment. To carry out maintenance and testing, these sensors can be provided with block valves for isolating them carefully from the process liquid. Direct contact with the medium. Numerous alternative design variations and sensor technologies for almost every application. Limitations: unsuitable for bulk material. Accurate measurement requires either media with constant density or continuous density measurement of the medium.